Consider the relation represented by this arrow diagram. That's what it's called. I don't know if I called it that in the lessons, but you had an actual diagram. You should have recognized the arrows concerning the number of colored marbles in a bag. And so represent this relation as a set of ordered pairs. So if you go, right, you're supposed to write down red goes with 7, and black goes with 12, and yellow goes with 5, green with 12 as well, white goes with 5, and blue goes with 10. Okay. State the domain. If you're stating the domain, you're just stating basically red, right? Red, black, yellow, green, white, and blue. Like that. The range would be 5, 7, 10, 12. And from lowest to highest, I would take off half a mark if you didn't do that. Okay. Is this relation a function? Explain your choice, be specific. So the answer would be yes, right? Because there's no same color pointing to different y values, right? Like you don't have red pointing to 7 and 12, right? So all of these on the left have a unique y value. You do have white here and yellow both pointing to 5, but they're different colors. Okay, that's the point. So you want to basically scan every single x value and see if there is more than one arrow going to the right side. Then it would not be a function. Okay. All x values, colors, have only one arrow pointing to a y value number. Okay. So in this case, we have colors, but it could have been various things, right? But you don't have green pointing to 12 and 10, or you don't have yellow pointing to 5 and 10, something like that. That would not be a function if that were the case. Okay. So 3 marks for question 1. How is it allocated? I would give you 1 mark for this, and then I would give you 1 mark for A. Sorry, 1 mark for A, and then these two combined would give you 1 mark. So half for the domain and half for the range. Okay, that's how I would break this down into 3 marks. Question 2. A car is traveling from Winnipeg toward Brandon. The equation D is equal to a negative 90t plus 250 represents the distance D in kilometers from Brandon after t hours of driving. Write the equation for distance in function notation. So when you have something like this, you want to have the variable over here, which is kind of like our x, show up like this. D, distance in terms of time, is equal to minus 90t plus 250. Like that. So you get a mark for that. Determine D 2.5. So distance traveled after 2.5 hours. Okay. So we're going to go D of 2.5 is going to be negative 90 times 2.5 plus 250. And so that'd be negative 225 plus 250. And that gives you 25 positive, right? Distance of after 2.5 is 25. And that should be kilometers because it's distance in kilometers. I'm just going to double check if that is all good. Yeah, it is. Okay. So what does it explain what this represents? Okay. So you're leaving from Winnipeg towards Brandon, right? So think of it this way. This is Winnipeg, this is Brandon, okay? This equation represents the distance in kilometers from Brandon. So if you're traveling towards Brandon, there's less and less of a distance to Brandon. Like if you're looking from this way, there's less of a distance remaining, okay? Looking from Brandon. So it represents the distance from Brandon after 2.5 hours, 2.5 hours. Something like that. It represents a distance from Brandon after 2.5 hours. So after traveling 2.5 hours from Winnipeg, right, there's a distance of 25 kilometers from Brandon. Okay. Determine T if D of T is 70. So this is your Y value here, if it's written like that. So in the function, you replace that with 70, and then you have negative 90t plus 250. Okay. And so what you do here is you bring this over, and that'll be coming over subtracting. So 70 minus 250 is equal to negative 90t. This gives you negative 180 is equal to negative 90t. Divide both sides by negative 90, because remember, you always want your variable to be positive. So t is equal to 2, and that's hours. Okay. Explain what this represents. When the distance from Brandon is 70 kilometers, the car traveled for 2 hours. Or after traveling for 2 hours, that's another way of putting it. After traveling for 2 hours, there'll be a distance of 70 kilometers from Brandon. Either way works. I know it's worded in a weird way. It doesn't tell you the distance traveled after leaving Winnipeg. It tells you how much is remaining from the other end. So it's a little bit, it's worded differently, right? Okay. Let's keep going. So this is the stuff we did at the beginning. But I'm going to keep, this is going to keep showing up from time to time. Given f of x is this, find the following, leave answers in simplest fractional form. Okay, so f of 9 is going to be negative 4 over 3 times 9, right? We place the 9 in for x, so substitute that in. And so that'd be negative 36 over 3 plus 6. And that actually, 3 goes in there 13 times, right? So that's negative 13 plus 6. So f of 9, this is my last line here, would be negative 7. Okay. And then they want x if f of x. So when it's written like this, that's really the y value, right? So we're going to place the y value. We're going to replace f of x with 26. And that leaves you with negative 4 over 3x plus 6. And now what? Bring the 6 over first. Remember, this is multiplying and dividing x. Leave that for the end. Bring the 6 over. So it's 26 minus 6 is equal to negative 4 over 3x. That leaves you with 20 is equal to negative 4 over 3x. And now you can do this in steps if you don't like. You multiply both sides by 3 to get rid of this. That gives you a 60 is equal to negative 4x. And now we're going to divide everything by negative 4. So x positive is going to be negative 15. We have no units here, so we leave it at that. And I'm going to use this time to remind you of something. For 2a, isn't it? 3a. Oh, hold on. Folks are saying 3a, isn't it? You're right. My mental math, that's 12. Sorry, folks. Yeah, so that'd be 6. Is that what you were saying? Yeah, Christine. Yes, Timmy. Yeah. Thanks for letting me know. Please change that. That's negative 6. I'm going to use this moment to remind you, what did you just find? What did you just find? Here, you found the point, an ordered pair of when x is equal to 9, y is equal to negative 6. You found that point on that. You will find out that this is a line down the road. Over here, you found that when x is equal to negative 15, y is going to be equal to 26. Okay, that's really what I want you to be thinking in the background. That's what you're finding. So that this is what was unknown to you here, and this is what was unknown to us on this side, right? So they might ask for one or the other. Usually when the y is missing, it's the easiest one. You just plug in, substitute, do your math, you get it. If they're asking for x, it's going to be a little bit more algebra, knowing your steps, right? It's going to be important there. Showing your work. Right? All right, another one here, the domain and range part. So I want this in set notation, interval notation here, and then both for that last graph, okay? So the domain in this case is just negative 2. That's it. That's it. The range, and this is discrete, right? I forgot to ask for it next time. This is discrete data. I actually meant for you to write down discrete or continuous, but I didn't write it down, so it's on me, right? So, and the range here, we are at negative 3, negative 2, negative 1, 0, 1, 2, 3, right? So the range happens at negative 3, negative 1, negative 2, negative 1, 0, 1, 2, 3, right? So the range is bigger. There's more data points, but for the domain, it's always negative 2, right? And we don't repeat. We only write it down once. I just want you, and maybe we'll do this in our notes later. We have only 8 minutes left. There is no interval notation for something like this, okay? I think in the key I may have done this, right? Interval, that's not there. It's just not applicable. You can't do it. It's only a set because interval you need a beginning and an end, or at least 2 values. So here for the domain in interval notation, right? For the x, you are at negative infinity, not included, all the way to positive 4, also not included because it's an open dot. The range here would be also negative infinity, right? Because you're coming from negative infinity all the way to the highest point, which is 2, and that is included. I would just go right or wrong today. I wouldn't try to take out little bits and pieces. Like if you get it right, you get it right. If it's wrong, it's wrong. Okay. Here, the domain and interval notation, we're going from -1, not included, to, I know this is my bad. It should have touched here. So I hope that you put down 3. If you didn't, that's fine. If you put down 2.99 or 2.98, I will take that. But it's included here. It's not included here, right? Because the left limit is not included. The right limit is. So square brackets here. The range, we're going from -4 included, right? That's the lowest, all the way to 0, which is not included. Okay. So basically, the domain, you just rewrite this one, right? It would be -1 greater than x less than 3. Okay. And then for it's -4 greater than or equal to y less than 0. And we know that this is continuous and this is continuous as well. Okay, just make a note of that. Okay, so how does this work? Mark-wise, you get 1 for each pair. So basically half a mark per entry. Okay, for question 4, it's worth 4. So half a mark for each entry. So if you make a mistake, you just lose that half a mark for today, okay? That's how we're going to do that. Okay, I'm going to stop this here.